Okay, so in this video we're going to talk about how to convert repeated decimals into fractions, be it improper fraction or proper fraction. Okay, so the first example is 0.4 repeated. How do we convert this to a fraction? Notice that we can start by assigning the x value to 0.4 repeated. So we're going to basically set x equals to the given repeated decimal. The next thing we're going to do, so our goal is to basically get rid of the 4 repeated decimal, right? So we want to get rid of this 4 repeat, because otherwise we won't be able to figure out the fraction, okay? So how do we do it? First we set x equals to 0.4 repeated, then we multiply both sides of this by 10. So we're going to have 10x is equal to and if you multiply this by 10, you will essentially get 4.4 repeated, right? Because basically these are never-ending 4s. So you're moving, but when you multiply by 10, you're moving the decimal to the right. So you can express this 4 by itself, and then the rest of the 4s can be followed by the repeat sign. Okay, so now the next thing you're going to do, you're going to subtract the first equation that you created from this equation. And that eliminates the 0.4 repeated decimal. And that's what we wanted, right? Because if you subtract the first equation from the second, notice you're going to get 9x on the left side, and on the right side you're subtracting 0.4 repeated from the 4.4 repeated, right? So essentially getting rid of the 0.4 repeated, because one is subtracted from the other, and all you're left with is 4 minus 0, which is equal to 4. And now finally divide by 9, and x would be equal to 4 9ths. All right? So that's the fraction equivalent. It's a proper fraction, so we don't need to convert it to a mixed fraction. It's a perfect representation of a fraction equivalent to the 0.4, right? To the repeated decimal, to the 0.4 repeated. Okay. Now the next part is a little bit trickier, because here we have the repeated 2-digit number, right? So it's not just 4 that's going to be repeated, it's the sequence 3 5 that's going to be repeated. So basically it looks like 3 5 3 5 3 5 3 5, and that never ends, right? So how do we take care of this? Well, we can do the same thing. We can set x equals to 2.35 repeated. All right. Then we can now notice that in order to bring the 35 to the left of the decimal point, we have to multiply this x by 100 and both sides by 100 in order to get it 235 point and then 35 repeated after the decimal point. Okay. Now, of course, you're going to again subtract. You're going to subtract the x equals 2.35 repeated, the first equation from the second. And if you do this, you're going to get 99x is equal to, and notice again the 0.35 repeated is successfully canceled out, right? It basically turns into 0. And all we're doing, we're just subtracting 235 minus 2, which is going to be 233. So as a result, dividing both sides by 99, you will get x equals to 233 over 99. However, notice that this is an improper fraction, so we're going to need a mixed number for this. So notice that 2 99s go into 233, right? So we know it's going to be 2 of them. Now the difference between 198, 2 times 99 is 198. So the difference of 233 and 198 is precisely 35, right? Or you can think of 233 minus the twice 99. The difference is 35 over same denominator 99. So you have found your mixed fraction, mixed number representation of a 2.35 repeated. Now, so this was pretty straightforward, because all you had to do is just see where the decimal place was and accordingly find the correct multiplier in each case. In this case it was 10, in this case it was 100. However, in these subsequent, in these 3 remaining examples, you're going to see it's not going to be that easy as to just multiply by 10 or 100, because you will need to actually think of conversions before you do that. So notice here in this case, there's a 0 that comes right after the decimal point, and then you start repeating the 6 after that. So what I would do, I would convert this and write it as 1.6 repeated minus 0.6. All right? So notice if I do this, I have 1.66666, they never end, and I'm just subtracting 0.6 after that. Okay? So what that does is that makes it a 0 right after the decimal point, right? Because 1.6666 makes sure that the 10th place value is a 6 for sure. And I'm subtracting that 10th place value, so I'm having a 0 in the 10th place value. And after that, all the 6's that are repeated will still remain, right? And that's what happens. Now, why did I do that? I did that because we know that this result can be found exactly like the number 1 result, right? Because as long as we have the repeated decimal right after the decimal point, that's going to be easy, right? So you're going to set x equals to 1.6, repeated. You're going to multiply both sides by 10, right? Because you're talking about only one repeated decimal after the decimal point. So you just need to multiply by 10 to move the decimal once. Right? So basically that's going to be 16.6 repeated. You subtract the first equation from that, you're going to get 9x equals to 6 repeated are gone, 1 subtracted from the other, that's 0 there. After the decimal point, 16 minus 1 whole numbers are subtracted, you get 15. Divide both sides by 9. X would be 15 over 9. Now 15 over 9 is what? You can divide, reduce this by dividing by 3, right? The GCF of that, so you're going to get 5/3. All right? So what that turns into now, we found this result, right? So it's going to be 5/3 minus 6/10, right? 0.6 is 6/10. And so 5/3 minus, you can reduce this and divide by 2, so that's 3/5. Okay, now the LCD here is 15, right? 3 times 5. So 5 times 5 minus 3 times 3 divided by 3 times 5, right? So what that does, it gives us 25 minus 9, so that's 16 over 15, and that gives us 1 and 1/15. And that's precisely the answer equivalent to the 1.06 being repeated. Right, for question number 4, again, what we want to do, we want to eliminate a digit right after the decimal point that's not repeated. Right, and notice that 7 is not the same number as 3, so we need to get rid of it somehow. So what we could do, we could write it as 0.3 repeated plus 0.4. Now what does that do? That basically tells you that the first 3 after the decimal point, because 3 never ends, right? It just starts from the 10th place and goes continuously until, infinity, right? So 3 after the decimal point is the 10th place, and you're going to add that first 3 that you see with the 10th place that's here a 4. So with that in mind, you're going to get a 7 in the 10th place. But then 3, since 3's just keep repeating, you're going to have 3's in the 100th place and on and on and on anyway. Right? So you could split it this way. And again, this is very convenient because we know we can work this one very easily by setting it equal to x, multiplying it by 10, because there's only one repeated digit right after the decimal point. Right? So that's going to give us 3.3 repeated. Subtract the first equation from the second. You're going to get 9x equals 2. 3 repeats are gone. 3 minus 0 is 3. Divide both sides by 9. You're going to get 1/3. And actually, you probably realize that 0.3333 is 1/3. But if you didn't know that, you could, of course, just find your safe way out and just solve for it. Right? So what that is 1/3 plus 4/10, right? 0.4 is 4/10. And of course, 1/3 plus, divide both by 2, you're going to get 2/5. The LCD is 15, so think of diagonal products here. I would say it better that way. So that's going to be 1 times 5 plus 3 times 2 divided by 3 times 5. So that's 5 plus 6 over 15, which gives us 11 over 15. So that is your fractional equivalent to the given 0.73 repeated. Now the last example, it's going to be a little bit more challenging. Actually, the most challenging example here, because we have two things to worry about. We have two digits that repeat as a string, right? 7, 8, 7, 8, 7, 8, 7, 8, forever and forever. However, we also have a problem because we have a 2 after the decimal point that is not in the repeated sequence, right? So it's outside and it has nothing to do with numbers 7 and 8. It's a separate number. So what do? We first, again, we need to think of conversion, right? We need to get rid of that 2 somehow. So what we could do, we could write it as 4.878 with a bar, okay? So notice 8 is not going to be under the bar, right? It's just going to be there in order to work with getting rid of that 2, right? And then we're going to just subtract 0.6, right? Because you're working on the tenths place, right? You want to work on the tenths place. You want to express the 2 there, 2 tenths, as the difference of 8 tenths and 6 tenths, because 8 tenths minus 6 tenths is exactly 2 tenths. You're only working on that place value and nothing else. You're keeping the 7, 8 with a bar on top, the string of 78 repeated, intact, right? So now what does that do? Now notice another trick, because why did I choose an 8? I chose an 8 because if I have a 7, 8 repeat, I might as well think of it as 87 being repeated, right? Because the sequence never ends. It doesn't matter what order I choose to start from, right? I can make it 87 repeating, 8, 7, 8, 7, 8, 7, or 7, 8, 7, 8, 7, 8. So what I mean by that is I can make it look like 4.87 with a bar, okay, minus 0.6. Because this is essentially the same never-ending quantity. Well, I should say it's a rational number because it ends, it has a definite string that repeats, but it's the same value, this string, as this, because 8, 7, 8 repeats, 7, 8 repeats just as well as the 8, 7 repeats, and no one tells you where it's going to stop and which one's going to be an 8 first and which one's going to be the 7 first as the last digit. You never know, right? So you can easily express it as 4.87 with a bar on the top. So what does that do for us? We can work on this one. We can easily work on the x equals 4.87 bar because we already know from this example number 2 how to solve it. You multiply both sides by 100, and why? Because here we have a decimal point and we have 2 digits in a string that's being repeated, so you want to bring the decimal twice to the right. So you multiply both sides by 100, so you're going to get 487.87 with a bar. You subtract the first equation, and you're going to get 99x on the left side. 87 bar goes away. As you can see, 487 minus 4, just the difference of whole numbers, is going to be 483. Divides both sides by 99. You're going to get x equals 483 over 99. All right, so now 483 over 99 can be reduced by dividing both numerator and denominator by 3. So if you divide that by 3, you're going to get 161 over 33. However, that's not yet a, well, actually we can work with this because we can just write 161 over 33 minus 6 tenths. So what is that going to do? 161 over 3. This can be reduced as dividing both by 2, 3/5. All right, so you know that 33 times 5 will be the LCD in that case. So what that does is that you're going to have to multiply 161 by 5, and then minus 33 times 3. Again, think of the diagonal multiplication. I'm not going to say cross multiplication because this is not an equal sign, but think of diagonal multiplication in order to achieve the correct numerator. And then 33 times 5 on the bottom. Right, 161 times 5 is exactly 805 minus 99 divided by 33 times 5, which is 165. All right, so what that turns into is 706 over 165. Now, how many times 165 goes into 706? Your answer is actually right there. It's 4 times, right? Because this quantity is represented by this given mixed decimal repeated number, right? So 4 times 165 goes into 106, right? So 4 is definitely that whole number that we're looking at in the mixed fraction. And then the rest of that is basically 706 minus 4 times 165. So that gives us 4 and 46, right? 4 times 165 subtracted from 706 is 46 over 165. So this, ladies and gentlemen, is your mixed number equivalent to the given decimal with a repeated bar on top of it. Thank you so much for watching. I hope this was fun and helpful. See you in my next videos.